This one's on LLMs. I just want to have a good resource for LLMs and how to think about them. Probably the most popular AI model right now, right, is an LLM. ChatGPT is powered by an LLM, although of course other models are used to give it its agentic abilities. But I think that if people know anything about AI models, then LLMs are the ones that they're familiar with. They're the ones that really have pushed the AI interest. And then if you also look at it, I don't know if you have to use. I guess at this point you would have. I don't know if people are using anything besides an LLM for something agentic, right? If you're building an agentic system and you're having something doing reasoning, I guess you could build out the reasoning logic yourself. Not really what we're talking about. And otherwise, you're using an LLM, right? And so then if you look at, say, the past few years of interest in AI going from LLM to RAG systems to agentic systems, including MCP, it's all LLMs, right? And so having a good sense of how these models work, I think, is really useful and cool for everybody all the way around. And then, yeah, so we'll do that today. I don't see many new people on the call, or any new people on the call. Maybe some will trickle in. And then, yeah, we'll do the LLM talk today. News, AI news. I already talked about how we're going to have, it's Genesis. So that's going to give us more, potentially more AI infrastructure in America. Hopefully push for it. I saw that Google has something that they put out, like some sort of agent system, I feel like, that they're doing, or some sort of agent platform. I haven't looked into it at all, though, but I keep on seeing something that Google is doing something that's going to make you way more productive. I feel like that has to be agents, right? But I have not had a chance to look into it. Flux 2 came out for anybody who's interested. So Flux 2 is pretty cool. I have not had a chance to test it out yet. I am actually going to test that one out. Flux is an image generator, pretty good one. I think that a lot of people are on the Flux system now. It's pretty popular on those image and video generation platforms that allow you to connect to any of these models. And I feel like Flux was one of the first ones that really pushed that it was good at doing text in it. I think so. The other thing with Flux, so Flux is essentially a nano banana competitor. But it's open source, right? So if you saw, is that Wednesday? I found the HeyGen open source competitor, which I do want to check out because HeyGen, I feel like, is kind of whack. It's really for when you pay for it, you don't even get all of that cool options. And so I am going to check out the HeyGen open source model to see what it's like, see if it's competitive. If it is, that was always the one where it's I could never find a good open source AI avatar system. And I was it's the one model type that does not have an open source solution for it. But that might be, hey, every model type you want has an open source solution. You don't need to be paying API fees. You can set them up and host them yourself. That always obviously comes with some caveats and issues. Flux is an image generator, but then it also does image editing. And and it's supposedly, and it's interesting how these things come in cycles. I wonder, is Flux 2, how is it that Flux 2 is so soon after Nano Banana Pro, right? How are these things so much in alignment with each other? Question, right? And it's the same thing with I think Seedream is another competitor. Seedream is just going to come out with their newest version pretty soon. And what goes, I don't know of an explanation for that, where do they just use Nano Banana to train their AI model, and then just, since it's out there, just boom, let's just slam it and use it for training? Is it just everybody's just kind of syncing up on their dev cycles? How is it that everything is sort of that close, that the competitors are able to release something that close to the flagship releasing something, right? Where again, like in this example, Nano Banana came out with a new version, and then boom, Flux is like, yep, we got a new version too. Crazy, crazy, crazy. Okay. If anybody has any questions, they can go ahead. I feel like this might be, I don't know if I would say like a shorter call, but we only have a few people on here right now. Day after Thanksgiving, I can understand. I feel like, especially we do seem to have a lot of people in the States on our calls. And so I can imagine people are a little turkey hungover and maybe not as quick to just jump on a coaching call today. But they're going to miss out. We're going to do LLMs. Of course, all of these are recorded, and so you can check in on them later. That won't be necessary for anybody who's on the call now. Let me pull up my presentation of LLMs. Open. Boom. Of course, generated these PowerPoint slides using Gamma. I'm using Gamma more, especially for this type of thing. You can't beat that price. Although the what would you say? Now where is it? That's gonna be important. Okay, I didn't lose it completely. It does have the 20 slide limit, which I'm not super thrilled about, but for our purposes, it's also making me like, okay, try to keep things within 20 slides. And then share the link, load. Just if anybody wants to follow along, maintain proper protocols and all that. Tomorrow's Saturday, obviously. I feel like a lot of the people on this call are fairly, although we try to, it's interesting. We have this big push to make ourselves more efficient and work less. I was about to say, I feel like a lot of the people on this call actually work a lot. A lot of people who are hustling, who are entrepreneurs, who are trying to make things happen, and that, ambitious mindset has everybody working way too much when really, AI is supposed to have us working less. Just never works that way. Okay. All right, so that's going to be the presentation we're going to do. And then, okay, hold on really quick. Let's see. We do have a new person on the call, Nay or Nye, potentially Phillips. If you want, you can turn on your mic or drop something in the chat. Introduce yourself.
Hi.
Hi. How do you pronounce your first name?
Nye.
Nye. Okay, that was my first guess. So Nye, what brings you to AI Profit Boardroom and these coaching calls the day after Thanksgiving?
Well, well, he always pops up in my feed. I think I am subscribed to him on YouTube, and I think I was in the old school. And I remember I what do you call it? When you accept the calendar link, but the calendar link, it had it being overnight. How do I explain? Instead of 11 to 12, it was just continuous. So I had put a what do you call it? Support ticket in. I was like, hey, you guys need to fix your calendar because something's wrong with it. And they're like, oh, well, that's the old one. You need to join the new one. I was like, oh, there's a new one. Okay. Here I am.
Here you are with the
I want to get this right. I want to get this right, like seriously. CEO, understand this, make it my bitch, and just help as many small business owners as I can. I need to do this. I want to do this correctly.
So you're interested in AI for SEO, or for like what purposes are you looking for AI and automation?
I am a virtual assistant currently, playing it small, admin tasks, bookkeeping, and I want to grow. I need to grow. And so AI is the way to go. So I need to know how to do it properly.
Okay. So a few things I would say, and this kind of goes to something I was talking to somebody else on the coaching calls with earlier. I feel like one of the first steps. So do you use ChatGPT often for your work?
Yes, I do.
Okay, that's a good start. How do you feel your prompting is, like that you're getting the most out of ChatGPT when you prompt?
I get the most when I speak to him instead of because it's what I feel. It's easier somehow to get what I need when I speak to him in verse, instead of, oh, this person said it should be this instead of this for me, and buying all these prompts all over the place. And no, let me just talk to him, tell him what I need, and he For
Yeah.
me, that is.
Yeah, and I think that because there's two different ways of working with AI. One is the one that you're doing, right, where you're on the ChatGPT platform and you're interacting with it directly. The other one is where you connect to their service through an API and you set it up in your N8N or you set it up in your application or something like that. And I do think that now with how good it is at understanding things, that a lot of times you can be way more casual in your prompting and just like get to the point. Like, what are you looking for? And it's a lot better at just understanding what you want and then just giving you what you want. A lot of these sort of prompt techniques make way more sense when you are just tapping into their service and using their API because it works differently. And that's what we'll be talking about today, actually, a little bit. Cool. So you want to use it for admin
Sorry,
tasks? Go ahead.
I was going to say that's great because I have no idea what API is, so that'll be awesome.
Cool. Okay. Well, so like let me just give you that as a quick concept. So are you familiar with N8N or any of like the N8N classes that we have here?
No.
Okay. I will give you a quick overview and then we're going to move on to our presentation. So N8N is probably the most popular AI automation platform. And so what it does is it allows you to set up these little nodes. Node is just like, this is like a little box that you can connect to each other that does a task, right? And so you could set one up, we'll say for your purposes essentially, where what it would do is it would have a node that would check Gmail for new emails, and then it would take in those new emails, and then it would send it to the next node, and that next node would send each email to essentially ChatGPT, but not ChatGPT, to the OpenAI API, and have it respond to the email. So like write a response for it, and then you'd have another node, and it would send that response to that node, and it would actually put it into a Gmail email and send off the Gmail email. And you can have it do all kinds of different things. You can set up these automations to write blog posts for you, to send outreach emails to people, to do all kinds of different things, to create videos for you. And so N8N allows in your automation, and they're called nodes, and then they're connected to each other. So it's like one would do one step, and it's connected to the next one, and it does the next step, and it's the next step. And then even without N8N, no matter what, so like a lot of these AI tools have what's called an API. And an API is essentially a way of you connecting your project to their AI tools, right? And so what you would do is you can look this up. You can get what's called an API key. And so an API key is kind of like your login. You think about it that way. And it's like, like how you have a username and a password. Now you just have the API key. And it allows you to say in your N8N platform, or if you were going to build your own application or whatever you're going to do, you can now use the LLM use it for writing emails. And the reason why you'd want to set up an automation like this is so that what it'll do is it'll go through and do 100 emails all at once, or however many, right? Like it'll just do 100 or 1,000, whatever you're looking for. As long as it has something in there, it will just go over it over and over and over and over again, instead of having you sort of like go to ChatGPT, copy the email, ask for a response, paste it back in, send the email. This will automatically do everything for you. And so ChatGPT is one of them, but like most major software platforms have an API that you can connect to, right? And then other like image generators or video generators, or even like QuickBooks, or all of these different platforms have API keys where you can connect to them and then set up an automation where you access that software and its ability and then connect it to AI and have it do work for you. It's essentially the concept. Does that make any sense, or do you have any questions?
In the beginning, it sounded a little like Zapier.
Oh, so Zapier and Make are the competitors for N8N.
Oh, okay, cool.
Cool. All right. Nye, welcome. Thank you for joining us. Hopefully we can help you grow and expand and use AI to its fullest. Okay. And so, yeah, if anybody wants the presentation is here in the chat. I think I made it shareable. And then, all right, let's get started. Let me share screen, entire screen. All right, so, okay, we're going to talk about LLMs. We're also going to talk about SLMs and then VLMs. It's mostly going to be LLM centric, but then I also wanted to have a little bit about SLMs and VLMs since they're pretty similar, right? They're sort of related to it. And just very quickly, and we'll go over this. So LLM is large language model, and it is essentially exactly what it sounds like. It is a very large model that handles languages. SLM is a small language model. And then VLM is a vision language model. And SLMs are becoming more and more popular because, they're making these LLMs bigger and bigger and bigger, right? Bigger and badder. GPT-5, right? Sonnet 4.5, Opus 4.5, all these big, better, huger context window LLMs. But then these are larger, right? They take up more money, essentially, if you're using the API. If you need to deploy them, they're using more resources to deploy them. But then too often we're using them for very simple-ish things. Like we don't necessarily need those huge context windows. We don't necessarily need it to be trained on the newest data. We're having it like handle, things that you want to have an LLM handle, but it just does not need to be all that, right? And so then that's a use case for SLMs, right? Where people are just noticing, hey, if you use an SLM or a fine-tuned SLM, you're getting the same value. Like you're not seeing a drop off in the LLMs, and your latency is a lot less and your overhead is less. Like, hey, maybe this is just a better choice. And then a VLM is a vision language model. Essentially what you do is, the best way I can describe, you take an image and you turn it into a bunch of text, sort of, or tokens, and then you're able to then ask that model questions about the image. And it can be pretty useful because, there's certain things. I'll tell you that a VLM isn't super accurate for a lot of tasks, right? So like OCR is a popular one that I talk about. Even like object recognition, there's just these things that it's like, you can always find a better model to do very, very specific tasks, vision tasks. But when it comes to something that's like very, I think that it can work well when you're doing something that's, I don't want to say like esoteric, like sort of more conceptual about an image. Like, tell me about this image, right? Just like if you wanted to describe an image for you, and then using that description to do something is better. Whereas you're not going to get a description from OCR of what's in an image. Not necessarily. You're not going to get a description of what's an image. And so like if you needed to just like classify or categorize a bunch of images for whatever reason, if you were doing that, or extract out like the concept of an image, a VLM is better. Whereas again, like if you're doing some of these other tasks, you would want to use another vision model. But again, like the VLMs are part of the LLM ecosystem, essentially. A lot of the companies that have LLMs also have a VLM, or VLMs. There's like a lot of overlap, and like it is the same model. All right, so what are languages? So this is how machines learn patterns in text. So that's like if you look at a lot of what AI is, and then even what like I is, right? Intelligence, like it is pattern recognition at a very real level. And so then one of the things I think that most people don't realize, and that you will hear me bring up a lot, is that an LLM really predicts the next token based on all the previous tokens. That's like at its core how an LLM works, is that it uses extremely complex math to predict what should be the next token. And if you're not, so a token is basically, it's like a small word or a part of a word, right? And so if you look at, when you have a query and you send your query to the LLM, based on what those words are, it will predict what should be the first word that it's going to respond with, and then based on its first word that it uses for response, what's its next word, or its token, essentially, and then yada, yada, yada from there. And so that is, I think, important to understand why, what you're getting out of this, right? Because a lot of times people are trying to use LLMs for everything. Yeah, for like everything, right? Essentially. And it's not necessarily great at everything. That's not where it's best at, right? It's really best at doing this, which is being conversational. Being conversational, or like transforming, understanding that, hey, I got this set of words, this makes sense, these other words, because like a lot of times, before, when we were using like other methods for text, right, it had to be the exact word, right? And so when you don't have like the exact word and language, an LLM can be really useful as sort of like a fuzzy logic sort of text, what do I say, a fuzzy logic text node, or interpreter, or something like that, right? But like other things where it's like, oh, well, like I'm using my LLM to predict the stock market. It's like, no, you shouldn't do that. You should use the LLM to take in your natural language commands and transform that into commands for a predictive analysis model, something like that. And then once it finds its information, it can transform that information into a report for you. It can do these sort of language-based tasks. And yeah, like if you ask ChatGPT to do all this work for you, it will. It's probably not going to be very good, but it'll try really hard, or as hard as an LLM tries. So and then these are statistical engines, right? So this is all just really stats-based. These are all numbers, even though they look like words, but the words all get turned into numbers, essentially. The tokens get turned into very, very complex numbers. And they get trained over these huge data sets, which have different knowledge, style, reasoning, and domain patterns. So like it's really getting a good understanding of like how these text patterns work in different styles, and different ways of reasoning and things like that. And that's why it's really able to do this, a pretty good approximation of like sort of understanding what it's talking about when it doesn't really understand what it's talking about. But do any of us? So old models predicted the next word using only a few previous words, and so like that was like the old way of doing it. We're on transformers, and so if you ever hear this, so transformers are basically the model structure architecture that transformed everything, that really pushed generative AI. A lot of ways. Post-Thanksgiving yawn. And what they did is they introduced attention mechanisms, which is a little bit interesting. So enable models to consider all tokens at once, unlocking long-range structure, deeper reasoning, and scale. So what that means is, so like they used to have it where if you look at how AI models work, there's inputs and outputs, right? And you would put something in one piece of information at a time, and then it would flow through and you'd get an output. And then they came up with a system where, okay, like here we have what's called an LSTM, long short-term memory system. And so, okay, like here you could put in pieces of information, and it would actually remember that there was another piece before it, right? Which is cool. But then everything had to be put in the same order, right? But like then it did give it the ability to analyze temporal data, right? Temporal data is data over a certain amount of time. And so you could use these to analyze, again, like something like the stock market or marketing data, anything that had a time, concept to it, instead of, other things that are more static, right? Where it's like, well, here, if I just want to do an OCR run, it's like, well, it's just looking at this one image and then it's giving me an output for that, right? It only has one image. But if I'm looking at marketing data, then every, or stock market data or weather data, right? It's like every data point is related to every other data point based on the time, right? The weather today is based on the weather yesterday. And the weather tomorrow is based on the weather today and yesterday. It's the same thing with speech, right? The words that I'm saying are based on the previous words that I'm saying. And so at first, when we have a system where every word, when the system takes it in, has to have it in the same order when it comes in, then you're still reading everything in word by word by word, right? Everything has to come in the same order, and that is slow. Transformers, what they were able to do is, as it says here, they were able to consider all the tokens at once. So you no longer needed the order to be, that you no longer needed the inputs to be in the right order. And what they did is when I said that they transformed these tokens into very, very complex numbers, that's part of the complexity of the number, is what the order that token is in the whole thing, right? And so I don't need to put the tokens in a specific order if, when I've transformed them into a number, that number now represents its order, right? So if I have part of the number is like what the actual token's definition is, right? But then another part of the number tells you what order it came in, then you no longer have to worry about that. But it also will tell you, part of the number is how it's related to every other word in the in like the what do I say, the group of words that we're putting in there. And for instance, we use a lot of pronouns, and not just like if he, she, him, it, or they, it, something like it, right? I went to the store, I did not like it, right? Which is pretty simple. The I don't like it, that I'm having there is the store, right? The AI needs to know that those two things are the same thing. And that is also part of the tokenization process, or not the tokenization process, the and the transformer attention system is knowing that those two words are related to each other. And having that sort of understanding allows it to be this transformative AI model. So the transformer architecture, so self-attention highlights relevant parts of a sentence. It lets the model see different relationships, refine meaning and representations, and stack layers produce increasingly abstract understanding. So like this is, if you hear about transformers, this is, what it is. And it just allows it to be, again, like if you ever look into these transformers and the math that go into it, it's highly, highly complex, but it is allowing it to understand these different relationships, what actually is relevant, having a more abstract understanding of the words. And all of that is necessary for conversation. And you yourself are doing this all the time, right? At some level, you are doing this and you don't even realize it. You're just so used to doing it from language that you don't realize that you're creating all these different relationships in your head for all these different words. But you do, and that's how you understand everything that people are saying, or most of what people are saying. Okay, and so then context window. So context window is important. The more, I would say almost like the larger they make these context windows, the less important they seem, but maybe that's wrong. I don't know. I know that it was definitely much more of a consideration when you were building things that like there was a context window. And what does that mean? So essentially it's the total amount of text a model can see at once. And so this is why there used to be much larger limits on, or no, much smaller limits on like the size of the documents you could upload to an LLM, or even like the length of a chat, right? And then you get to a certain point and it's like, oh, no, we can't do this chat anymore. And they keep on figuring out ways to either expand these context windows or do smart solutions to make it so that the context windows can take in more text. But essentially, the problem is that like at a certain level, it is going to lose the ability to do that task I said earlier, where it's like, oh, well, like I went to the store and I didn't like it. Knowing that the store and it are the same thing. If I have 10 billion words, the math is way too large and complex, or not even complex, it's way too much for it to understand the context, right? That the store and it are the same thing, that's context, throughout that entire thing. And so it'll have a limit. And these limits are getting bigger and bigger. I think now a lot of them are around 250,000 to 1 million tokens, which is pretty substantial. But it used to be much smaller, and much smaller for the APIs that we would use. Small windows limit reasoning chains and memory, exactly. So like I can't remember things across these different context windows. And the larger windows allow long conversations, documents, and workflows, right? So that you can have this information be carried from one thing to the next. It's sort of like, like if you have like a really just a finite amount of memory, essentially. Like if you were to talk to somebody and they could only have, brief conversations with you, and that was it. And then the next time you met them, they had no understanding of what you were talking about before. That's sort of like context window. Sliding windows and compression techniques extend practical use, right? And so essentially, again, like I was saying, there's techniques that they're using now to extend the practical use of the context windows. And if you're on Claude, I've been seeing this lately. I don't know if they were doing it before and they just weren't showing you or whatever, but you can see now where it'll compress your text so that it can practically extend your context window in your conversation. So it's not a search engine. It's not a database, right? I think people try to think about it that way. It scores all possible next tokens and chooses the most likely one. Okay, yeah, that's another aspect of this. And this is like true of all, like almost all AI systems, is that you will get an answer essentially, from an AI system. But typically what happens is it has a most likely answer and then other like next most likely and next most likely answers for everything. Because it's always guessing, it'll always be like, oh, this is the most likely answer. But then if it has one that's the most likely, there are ones that's like, yeah, this is like in second place. This is in third place, essentially. Emergent abilities appear as models scale. So they seem like they can do more and more and more stuff. But really, again, that ability to score all possible next tokens and choose the most likely one, that is actually its core ability. And from that, these other abilities emerge. And then the patterns of logic and reasoning arise from training data sets. So it's understanding how to do logic and reasoning from its data sets. But it's not, some of them get trained more on logic and reasoning. But, if you look at it, that is not necessarily what it's really meant to do. We talked about this for like emerging trends for AI, what's coming next in the AI world. And they are probably going to start having models that are just really much more built around logic and reasoning than an LLM. And then these are the ones I brought up previously: LLMs, SLMs, and VLMs. LLMs, these are for general purpose reasoning and language generation. These are just SLMs, smaller, optimized for cost, latency, and edge devices. So that's the other reason why I have them, is so that you can run them on different devices. And then VLMs, so they understand both text and images, and that way you can ask text-based questions about images. And powerful, as I said, powerful small models and hypermodality, like that's a lot of what people are pushing into. And again, because of these agentic systems and their usefulness in the agentic systems, to have these like really powerful small models or something that can do multiple, inputs. These are probably the most popular models, I would say. GPT, Claude, and Gemini, I feel like, I haven't seen the numbers. These are probably the most popular API-based LLMs. And then Llama. I wonder if I feel like Llama is still the most popular open source. Llama comes from Meta. Gemini comes from Google. Claude comes from Anthropic. GPT comes from OpenAI, right? GPT, strong reasoning, creativity, and reliability. I guess so. Claude, exceptional safety, long context, and analysis. I feel like the other ones are catching up with context. And then even like Gemini, I think really has like a very long context. Analysis, I would agree. I think that it's like much better at like reasoning and analysis, even better than GPT. Gemini, multimodal strength and integrated tools. I go along with that, but I think also there is a version of Gemini that has a very long context window. And then Llama is open source, right? So you can customize it and run locally. You can customize, I know GPT gives you the ability to fine tune it as well. But then that fine-tuned model, you can't like port anywhere else. It's, in your account and that's it. Whereas you can customize Llama, and now you have a customized Llama that you could share with other people. And yeah, they all have different strengths, speed, cost, stability, context, and you should be like, finding the best, not even just like the best model family for the job, but the best model within that model family. And like really, like something like costs. A lot of times you can really get away with using like say GPT mini instead of 4.0 or 5.0 or whatever. And it's just like, oh yeah, I want to use the newest, best one. It's like, yeah, it's going to cost you way more. And at scale, if you're not really using that, those larger context windows, or that higher processing power, that if you don't really need that LLM, the minis, the micros can be really useful. So pros and cons of leading models: great reasoning tool, higher costs. I could see that. That sounds about right. I mean, I think GPT is probably the most expensive one. Claude, long context and limited vision. Sure. Yep. And then Gemini, strong for images and search, inconsistent outputs in some areas. I've heard that. The Llama, customizable and free, but requires tuning for best results. I would say that's true. And then again, like, their greatest strengths are sort of their greatest weaknesses. The things that make them the best are also what is causing them to be, not as useful in other areas. And this is what, I've been saying about the small language models: lower cost per request, faster, can run on more hardware and devices, and then really for focused skills, right? And a lot of the times when we're doing agentic work, it does make sense to use these smaller language models. And then really also, like, a lot of times, you should be, even if you have a project that has like more text than what you would think a small language model would be able to handle, you should be breaking that task down into smaller tasks that would fit within that small language model's capabilities. And so VLMs, right, combine image understanding and language reasoning, image captioning, right? That's a good one. And that's what I was talking about. Like, what is in this image? Product classification, another one, where it's just like, hey, what is this product? And again, like, something that's kind of like a little bit messy, easier to like get it up and going a lot of times, especially for something like classification. Visual search, identifying, is this in this image? OCR pipelines, yes, you can use them. I really feel like, and maybe I guess like OCR models are considered VLMs on some level because they are multimodal, but like a lot of times the traditional VLM is not as good as something that is like, this is for OCR. I do a lot of OCR work, and I've just found that like, people be like, oh yeah, this VLM, it's great for OCR. And it's like, have you tried this other thing that's just an OCR model? And I keep on saying OCR. OCR is optical character recognition. And essentially what it does is it allows you to recognize words in an image, which seems like not that big of a deal. It's like, who cares? But like, you have to realize how many forms there are in the world. Contracts, IDs and identification. We have a lot of forms out there, and OCR gives you the ability to take that text in those images, right? So like, if you take a picture of a form, you scan it, now you have an image of that form, and be able to transform that information into like text that you can now put into a database or whatever you would like. This is a huge deal. This is one of the ways in which people don't realize that AI be transformative for what we do, because of just look at how much time people spend in certain jobs just going through forms, going through contracts, looking at IDs, stuff like that. If you just had AI that could do that, you'd save an incredible amount of time for stuff that people don't really want to do, right? People don't really want to look through insurance forms and enter the data in from them. That is not anybody's really dream job. And then a lot of the people who have to do that are being taken away from the work that I think all of us would prefer that they were doing, including themselves. Fine tuning. So if you hear the word fine tuning, people will use fine tuning colloquially, where they'll say, oh, we're fine tuning this. And it's like, yeah, I mean, you're not actually fine tuning it. Fine tuning is a specific process. And then I guess like the term fine tuning got adapted from the concept of fine tuning, right? It's really from like tuning an instrument, I think, probably, right? And so we're adapting it from that. So then sometimes it's like, oh yeah, like, I mean, colloquially you're fine tuning, but specifically you're not, which is you're taking an existing model and you're adapting it to a specific domain. So somebody already trained a model, they have a model, and then now you're just gonna like make it a little bit more in one direction. So you have full fine tuning, LoRa adapters, or prompt tuning. So like the difference between fine tuning and a LoRa adapter essentially boils down to, when you do fine tuning, full fine tuning, you actually change that base model. So like if you had Llama, right, you had the Llama model, and then you fine tune it, the new model that you have is different from the previous model that you had, and is now fine tuned and different. When you do LoRa, basically you have a new, smaller, tiny model that you use along with the original model. So instead of having one, say, big model that is now a different big model, you have the same big model and then just now a little tiny model that goes along with it. Improves accuracy in specialized tasks, yeah, and gives you like potentially like more domain knowledge. Requires high quality examples, not large volume. Yeah, typically, right? You needed that large volume to like say train a large language model, but then when you were doing fine tuning, you can fine tune with, it still might seem like a lot where it's like, oh, you need like 1,000 or 2,000 or 10,000, versions of it. Or it's like, yeah, but to do the large language model, you need a billion. The scale is just completely different from fine tuning to just training. RAG, so retrieval augmented generation. This came about because if you remember when ChatGPT first came out, it was really a toy. Like it was like, oh, look, that's cool. Like, you can do this with it. You can do that with it. It'll tell you a joke. Look, hey, you can talk to a computer. And it's like, all right, that's kind of cool, but it's hallucinating a lot. It's saying a bunch of stuff that doesn't make sense. And, we want to use it for our purposes in our company, but it's like, it doesn't know anything about our company. How can we really utilize it? That's where RAG came into place. And again, like, RAG was the hot topic in 2024. It's still very, 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 not well used, but like people have a lot of interest in it still in 2025, and it's going to be in 2026. But essentially, it became popular in 2024, and it is this concept that essentially, we're able to have the LLM utilize a external knowledge source to answer questions. So like if you have, say, knowledge about your company or your product, and you want the LLM to be able to respond to emails or in a chatbot format or something like that, and use the information that you have, then you want to use a RAG system. You don't want to do fine tuning necessarily, because that's not, and you could do both actually. Typically, like if you do fine tuning and a RAG, that will get you the best responses a lot of times. But the fine tuning gives it this really like ground truth sort of information that it can use. And what it does is it retrieves these relevant chunks and feeds them into the prompt. And so this is very, very important. I think that a lot of people think that with RAG, it's like, well, now your LLM just knows everything in the RAG system, and it doesn't really know everything in your RAG system. What it does is it retrieves the relevant information, and then it injects it into the prompt. So like if I were to ask, what is the best model car that this company sells, right? And then the company sells all kinds of different things, for instance, right? So, because I'm asking about a car, what it's going to do is first go and search the RAG system and find the cars and which ones are the best, right? And then typically it'll take, and like the RAGs are getting bigger, but like when I was first working on it, it's gonna take 3 chunks. So it's gonna pull a chunk, and it's typically, it used to be like 400 tokens, roughly, right? So like a paragraph, maybe you would say something like a paragraph or 2 or a paragraph and a half, something like that. And it would pull 3 of those most relevant ones. It would use semantic search. And so it would just like figure out which ones were the most relevant to best cars. And then when I asked which company or what is the best cars this company sells, it would send that information along with those 3 chunks of information to the LLM. And then the LLM would respond based on that. And so really a lot of times what that LLM is just doing, you think about it, is just taking all that information and just like remixing it all up, like Taco Bell style, where you go to Taco Bell and it's the same food, they just like come up with different combinations of it. That's essentially what they're doing here, right? Where it's like, okay, like here's 3 pieces of relevant information, here's a question, spit it back out in a different way. It does keep the responses accurate and up to date, because you can use this accurate and up to date information when the LLM is making responses, right? And then for enterprise applications and complex workflows, right? Like, so like for companies, again, like these big companies, they want to use these LLMs. It needs to actually know this information. Otherwise, it's just saying whatever, and like that's not great. LLM platforms versus LLM APIs. And this is what I was bringing up to at the beginning of the coaching call. So platforms like ChatGPT or Cloud provide a polished interface. It includes memory, projects, chat history, and built-in agent features. Right. So these are things that are built in when you're using the platform. APIs These provide raw model capabilities for developers. They allow full control over prompts, data, privacy, and integrations, right? So these are two different things. I keep on harping about this, that I think that people should really understand this, that like a lot of people who have not started to build, if you've never built with these before, this is one of the things you don't realize, but it makes perfect sense. Like that, all of that agentic, tool-based, memory and projects, all that stuff, that's just part of their platform. They've built that. You want that, you're supposed to build that. And typically you don't need to build all that. A lot of times people are using LLMs and they have a specific use case. And so they don't need all that stuff, although they kind of want it sometimes when they start building. So the platform focuses on user experience. APIs focus on flexibility and automation. Yeah, so you can use these APIs to do whatever you want, essentially. Platforms hide prompt orchestration for the most part. Sometimes you can see it, right? I think Claude gives you the ability to see more of the prompt orchestration. You could see like, I ask it one thing, it's going through and it is prompting a whole bunch of stuff. It is really doing a whole bunch more after what it gets from me, and does like thinking and reasoning. There's a lot of agentic work going into answering the prompts that we're giving it. But when you have the API, that lets you build your own orchestration, retrieval tools, and guardrails. You can do whatever you want, however you want when you have the API. Building with LLMs. So patterns include chat, structured extraction, agents analysis, creative generation, and classification. So these are like the different things you can like typically do with an LLM. You can combine your LLMs with tools like vector databases, so that's like RAG, essentially, search APIs, or workflow engines, right? That LLM becomes part of a larger system, right? It's just one piece in all these other things. And this is the same thing with like the platform, right? The LLM is one piece, and then you have all these tools and interfaces and projects and structures that you're able to use. Customer service and automation, content generation and marketing pipelines, coding help and software development, document analysis and summarization, research assistance, decision support, search, recommendation, and knowledge retrieval. I would say, this is probably right what LLMs are most used for, right? And if you look at this, it's a lot of text-based stuff, and our text-based work and workflows are going to be different going forward. And it's happening now. I think it's still on the fringes. Like I don't think enough people are probably using ChatGPT for help, or Claude, or whoever. But then even beyond that, the automations that are going to be implemented and used for all these systems. More capable small models, as I said, there's a big push for smaller models now. Especially for edge devices and things like that. Multimodal reasoning with text, images, video, and audio, just making it so it can really just understand all of these different, and we already have that, but like a lot of these things we have, and they're just going to push it. Longer context and memory systems, multi-step tasks autonomously, and safer and more controllable. Like if you look, these are like the bigger topics that everyone is looking for, and we're doing this, but then these are sort of the branches or the avenues that like they want to go down and they want to push the most. Okay, these are becoming foundational. Like these are possibly going to be in almost every technology we have. They're pretty much there now, but it's going to be a bigger and bigger deal. Understanding, sort of like how this stuff works, just like even like at a basic level, just keeping it in the back of your head, like so that you can do better prompting or better, working with it better, or if you're setting it up for your own automations, like having these things, understanding is like, like I need something like RAG, right? Or this is a good idea for fine tuning, right? There are context windows, things like that. Multimodal, integrated, and context aware. I could see that, like, and we are going to be probably getting that next generation of models in the next 5 years. That are really going to be different and changing things. And this is a new interface for both humans and software, right? We as humans are using it, but then this is a software solution, right? That allows us to create software that also has these LLMs to help them out and to make things easier and more interesting. Okay, that got us pretty far, actually. Let's see. All right, anybody have any questions? Otherwise, we have a few more minutes. Only have a couple minutes. Closing thoughts from me if nobody has any questions. LLMs are cool. Try them out. They are different from their API platform, or the APIs are different from the platforms. My phrasing I love, over prompt and under deliver. If you're using them in a automation platform, if you have this one big, huge prompt and you're asking it to do a whole lot in one node, essentially, you are going to not get the response that you're really looking for. Break things up into multiple steps, and you will get a better response. Okay. Thank you, everybody. I will see you on Monday, same time next week. Have a great weekend. Have fun with AI automation. And I will see you next week. Later.